cosine x times tangent x equals,
or no, 1/2.
Equals 1/2. Remember that simplifying we did?
Yeah,
I'm going to change.
Can you do that?
Yeah.
With this?
Yep.
Okay.
Tangent, you can do it forever.
Exactly. That's what I did.
Awesome. So you can do that. Change tangent to sine over cosine. This is cosine over 1. The cosines will cancel. And someone other than Trey.
Wait, hold on. How'd you cancel? Oh, wait, never mind. I get it.
Okay. It's always the
I get
6th,
it.
5th, 6th, 7th, 8th grade stuff. Someone other than Trey, what angles? And? Very good. Sine is 1/2 at 30 and 150.
That's easier than I thought. Okay.
That one. Yeah. Any identity, any simplifying, anything we've done is available. You do want to be careful sometimes. It's not going to come up this lesson, but a little later we'll get to situations where you want to look out for certain things like there is a difference between this statement and this statement, though. It doesn't create a problem at 30 or 150 degrees, but what's the cosine of 90 degrees?
90?
Yeah.
Cosine?
Cosine of 90 is?
0.
Got a couple of people know? Okay, 0. If you have a 0 on a bottom, you have an undefined expression, right? Okay, so at 90 degrees, this is undefined, and this is 1. So is this the exact same thing as this? Not at 90 degrees, no. But is cosine times tangent the same thing as sine at 30 and 150? Yeah, that'll work fine. I don't get a 0 on the bottom or anything crazy like that. So we may run into cases where you have to be careful with that, where you'll pull out some identity or trick that you've done before, and like I said, this is fine and is great as long as one of the angles you're looking at is not 90 degrees. If you're looking at 90 degrees, this is not equal to this. Does that make sense? Okay. Really depends on the question. Really totally depends on the question. What you do at that point is most likely your problem doesn't have a solution or it has an undefined solution at that point.
Somebody's going to be watching this video and hearing the noise.
Hearing the noises, I know. You're going to wonder what Tim was up to. Did I assign 26 and 28?
Yeah.
Awesome. Oh, I'm looking forward to 28. Okay, 26 I think I can fit in this space.
28 was easy though.
Good. I'm glad you think so. I'm going to, and this was 24? Okay, so 26, we have 2 cosine squared x plus 3 cosine x minus 2?
Yeah.
Excellent. Equals 0. Now when I substituted in the x's for this to make it look more like an Algebra 1 problem, Trey rolled his eyes at me. So I'm not going to do that little step. I'm going to go right to this one. And we're going to hope the textbook gave us something relatively easy to factor. So I need some pluses, some minuses, and some numbers that'll work.
Plus 3 minus 1.
It's got to multiply to -2.
You wrote this again. Oh, yeah, that works.
Does that work?
Wait, hold up. Yeah.
2 cosine squared
Yep, that works.
plus 4 cosine x minus 1 cosine x gets me my 3 cosine x
Minus 2.
minus 2. Remember those tricks? Remy, how's your Algebra 1?
It's okay.
All right. Now remember, now that I have factors equal to 0, I can do the trick of setting each factor equal to 0. If my factors multiplied to anything else, I cannot pull out this trick. I'm going to do this one first. I get a cosine x equal to -2. Someone other than Trey who already explained this. Does that give me any solutions? No. It's out of the range of the cosine function. This one looks more promising. This will get me 2 cosine x equals +1 and cosine x equals 1/2. For what angles between 0 and 360 do we get a +1/2 for cosine?
Positive?
Yeah.
6. There we go.
60 is correct for one of them. Now I need a 60-degree reference angle in another quadrant. Trey says 300
Yeah.
Yeah.
because it's quadrant 4 where it's positive. And that will, 300-degree standard angle will get me a 60-degree reference angle in quadrant 4. Any questions on number 26? Those factors without solutions are fun. All right, now we have 28. Cosine x plus 45 degrees, plus or minus, plus cosine x minus 45 degrees equals square root of 2.
Rather easy.
What do I do?
I distributed the cosine.
You can't distribute.
To what? No, for each one.
You can't distribute it like this. It's not algebra.
Then you do the cosine x cosine 45.
Bingo. You got to use the sum and difference identities. You can't do any algebraic distribution.
That's stupid.
Are you ever allowed to distribute inside the parentheses of a transcendental function, meaning sine, cosine, tangent, secant, cosecant, cotangent, or logarithm? No, you can never distribute into them. You can't reach into there. So what I have to do is pull out those sum and difference identities. That's why we bothered to learn them. So this becomes cosine x cosine 45 degrees. Is it plus or minus sine for this one? Minus sine x sine 45 degrees. But I need more room over here. Plus cosine x cosine 45 degrees. Is it plus or minus on this one? I have a difference.
Plus.
So it's plus sine x sine 45 degrees equals square root of 2. Okay, good thing to check here. I have minus sine x minus sine 45. I have plus sine x sine 45. What can I do with those? Minus sine x sine. They cancel out. Bye-bye. So now I get...
Couldn't you change the cos 45 in each one to the square root of the...
I absolutely could. And this is the same term.
And you get it's 2.
Excellent. I got 2 of these. Perfect. Okay, so now I get cosine x times the square root of 2 over 2 equals the square root of 2 over 2. The steps I did in that, here in between these two lines, I divided both sides by 2, giving me the root 2 over 2 and getting rid of this coefficient. And I changed cosine of 45 degrees to root 2 over 2.
And then you can divide by root 2 over 2.
Divide both sides by root 2 over 2 will get me cosine x equals 1. And at what values do we get a cosine of positive 1 between 0 and 360 degrees?
0 and 360.
Is Trey correct? Cosine is 1. Remember, cosine really means how far are you left and how far are you to the right on the unit circle. Cosine of 1 means you're 100% all the way to the right. That only occurs at 0 degrees, and again when you get back to 360 degrees. Any questions on this one, which was number 28?
Yeah. I have a question.
Yes.
What's the number for 9?
All right. It's more of these. They get a little more complicated, but you know what? I'm going to turn you guys loose on them.
We start now.
Remember it is? Yeah. It is page 460. 31 to 45 odd.
Do you want me to stop the video?
Not yet. You can hear this. Because it's odd, Danny, because they're odds, the answers are in the back of the book. I expect you to double check. Because the answers are in the back of the book, I expect you to show all work. Otherwise, no credit. So, show all your work and double check your answer in the back of the book. And if you got it wrong tomorrow, the first question I want to hear is, my answer did not match the one in the back of the book. Can you help me figure out why? And sometimes, you guys ever hear the term reverse engineering?
Yeah.
First, there's nothing wrong with looking at the answer to try and figure out where you went wrong after you've tried it the first time. Does that make sense? That's not cheating. Reverse engineering is where you take a product someone else has made and you try to figure out how they made it. Nothing wrong with that in this case. All right, and that's it.
You gotta do the code.